Hello, everyone. This is Dr. Uzair from Better Data, co-founder and CEO. And today I wanted to talk about the synthetic data landscape as a whole, and within that landscape, where Better Data comes in, and what are some of the models we use to generate our synthetic data. So as you can see on screen, this is a flow we have presented. So essentially we have two KPIs to evaluate models and techniques when it comes to synthetic data. So in general, synthetic data has been in the market for more than a decade, and one of the key KPIs for synthetic data has been how realistic it is. So on the left you have less realism, on the right you have ultra realism, and the second factor is how controllable and non-controllable the generation process is. So there are many more things, but just to keep things practical from a business point of view, those are the two key KPIs we have taken, primarily because when customers ask us questions, they are usually focused on these two topics. So in terms of the techniques, we can see we have things as simple as rule-based techniques, where you can define something and generate data accordingly. We have statistical modeling, Monte Carlo, engine-based simulations like gaming engines, for example, Unreal. So I play a lot of games. If any one of you is a gamer, you can understand that in developing a video game, we can simulate anything and everything. So those simulations and engines can also be used to generate synthetic data. We have agent-based modeling, which has recently taken a lot of traction given the interest and developments happening in the agentic space. But broadly speaking, everything when it comes to synthetic data and it taking the spotlight today is a function of generative models. So generative models essentially give you, in terms of control and realism, as much as is possible today. And we do expect and believe these models are only going to be developed further. They will only get better, and these two KPIs on realism and how controllable the generation is just going to get better as well, equally. Now, zooming in on generative models, and if any one of you is interested to know more about other techniques, please do reach out to Better Data or to me directly. Happy to share our feedback and observations on those as well. Zooming in on generative models, so one of the questions again customers ask us is, how do we go about selecting the right privacy technique, generally when we talk about privacy technologies, and when we talk about synthetic data, then what is the right model to choose? And for the last 4 years we have observed this engagement where a lot of enterprises, financial institutions in particular, are closely working with academia, because academia has this exposure to all of the cutting edge technology out there when it comes to privacy and synthetic data. And they kind of do this comparative analysis where they evaluate different models and tell the client which model performs the best, so and so. But again, as I mentioned, our focus today is on synthetic data, and just to answer this question, that how do we measure the success of the generation, as well as how to choose the right model for the use case. So on the left hand side, you can see when we talk about model classes, we have a lot of techniques ranging from imputation based to discriminative and generative, etc. But our focus again remains on generative model, because the task of synthetic data is generating data in nature, so it's generative. And within this model class, we have shallow learning models, we have deep learning models. So again, our focus at Better Data is in this domain, so focusing on deep learning models. And we work with tree-based models as well, which are not mentioned here. But traditionally, a lot of activity, a lot of spotlight, a lot of success that AI has seen for generative tasks is primarily anchored around the advancements in the deep learning and generative model space. So the left-hand side has more to do with how do you select the model. There are different classes, and what these classes entail, I will share in a minute. But that's the first part. And then equally based on the model chosen, we have this factor of how do we evaluate the synthetic data that is generated from these models. Again, you can see broadly two categories. We have data utility and information disclosure or privacy guarantees. And in turn, you have different metrics. So today the metrics, one note just on metrics is it's a function of what the academia, data science community, compliance teams, privacy professionals deem necessary is one. And secondly, sometimes data teams work with the data so they best understand what is possible and practical versus what is not. So it's an exercise that goes hand in hand between the synthetic data provider like Better Data and the end user who are using our technology to operationalize synthetic data in production. And it's a easy task for us because if a customer wants to see guarantees on any other metric they're interested in, we are always happy to put those in our quality assurance reporting, and they can just use the reports to evaluate the difference. But zooming out again, when customers ask us when we evaluate synthetic data, what are the key considerations? So broadly speaking, it has to do mainly with data utility. So does the data has the same quality as of real? And then data privacy. Is the synthetic data fully protected in a way that no one is able to take synthetic data records and re-identify real individuals out of it? And then how do we operationalize is something I'll share now. So moving on the model selection part. So this is the hallmark of our platform and our AI excellence. So the tagline I want to focus on is our thesis is to build the platform which fulfills most of, if not all of your data needs. So it could be that you have to share data, you have to access data for your AI ML applications. In most cases, it could be also the scenario where you don't have access to any data and you want to simulate something using custom logic, business policies, or simply user instructions. So we cover all of those scenarios, and we do so by offering you a wide suite of models. And what do these models do? Let's have a look. So as I mentioned, at Better Data, we are focused on helping enterprises suffering from privacy challenges and currently handling large volumes of data. So this data can be tabular in nature, it can be relational, time series, we can have text in tables. On top of all that, we want to detect and scan these data sets to understand if anything is sensitive in them or not. And finally, we are also working on our own tabular foundation model, which allows you to generate data using prompts, using instructions, using business policies and custom logic. So the goal here is, as you can see, the model type. We have tree-based models like adversarial random forest, and for relational, we have the sum product network SPN-based models. We have deep learning models like GANs with and without differential privacy. And ultimately, we are also customizing LLMs as well as foundation models to support tabular data synthesis. And from an application point of view, this is just to make the lives of our customers easier. So no matter what type of data they have, how large the volume or the quantity is, what compute or infrastructure they have, regardless of all of that, we give them the optionality that even if they are in a low compute environment, they can use our tree-based models and train models just on CPUs, versus another client who has GPUs and wants higher fidelity data. So they can provision GPUs and we can train the models accordingly. So again, as a customer, if you have data scenarios where you don't have data, where you have low volumes of data, where you have high volumes of data, we have all of the models to support those scenarios. And equally, the models reflect the requirements needed on the compute side. So we are flexible in terms of training our models not just on GPUs, but on CPUs as well. And for minimal workloads, we require extremely low compute. So it's nothing extravagant where we ask customers to provision us a very healthy, sizable workstation. It is never the case. And from an integration point of view, we can move things into production quite fast, assuming all of the infra and environment needed is provisioned and is there. So broadly speaking, when it comes to our platform, I mentioned a lot of things, but just to keep it simple, at Better Data right now, we do not support image, audio, and video-based synthesis. Our primary targets are customers who are handling a lot of private data, and they want to use this data to train our models and then generate synthetic data that is first representative and second privacy safe. So not only they can openly share it, but use it in their downstream application, be it on AI ML applications, data analytics, software testing, or simply working with third-party vendors in one country or any part in the world. On top of that, our team has been experiencing the advancements in foundation models as well. So for our expanded model innovations, we have benchmarked about 10 different LLMs, and we have been using them for different use cases ranging from PII detection all the way to time series generation, so and so forth. But broadly speaking, it covers everything I mentioned previously in regards to our core model suite. And from an application point of view, we are able to support most of the client needs when it comes to using synthetic data and then pushing things in production and getting those applications out into the hands of their users. So if you as a customer are dealing with a lot of LLMs with foundation models and you don't know which model is the best choice or the better choice for your use case, we have capabilities and experience in helping you out with that as well. And finally, when it comes to the data evaluation part, so we ensure the synthetic data quality is up to the standard or up to the requirements that users need. So again, previously I mentioned we have metrics on data quality and privacy. So on the quality side, we have different things ranging from statistical properties, which gives you like your typical mean, quantiles, standard deviation. So this is quite standard. Then we have data coverage, we have ML efficacy, all the way to quantification of privacy. So we have much more here, but the point is whatever the customer needs, we give them those guarantees. And in terms of our privacy guarantees, those are one of the best globally, so best in class. And we have done so by publishing tier 1 papers in reputable conferences globally. So this is just from a few months ago. Some of our papers on privacy metrics have been accepted by conferences happening at the Stanford University all the way to Google headquarters, titled Theory and Practice of Differential Privacy. So the goal here is our privacy evaluation is not just something that we advocate on, but it is backed by these publications. All of the science we have, all of the technology we have built is peer reviewed, and of course validated by the clients we are serving today. So finally, that was all for this session. Next session, I will explain how we typically engage with clients, what are those 3 steps involved, and what each step entails. So just to zoom out on, again, Better Data, everything we have made is made with love in Singapore. Again, what we do is offering privacy preserving synthetic data for enterprises. So if you are looking to move your AI initiatives from POC to production as soon as possible, please reach out. Thank you.